Hello, Angela. Thank you. Um, Good afternoon to everyone, and thank you very much for participating in this online launching of I Am for Manila Bay. And just to introduce our project and to link it to the other projects. So once Project Mapable is able to characterize and monitor the physical environment of Manila Bay or the Manila Bay environment, and then Project Iwasto and Chartered Dream is able to characterize and quantify the amount of pollutants that is generated from specific watersheds. What our project now aims to accomplish is basically characterize how these materials will be transported and mobilized in Manila Bay. So again, this is Eugene Herrera. I will be presenting about Project Smart. Next slide, please. Okay, so when we talk about water resources systems, we need to think of the bigger picture. So we cannot just think about Manila Bay. We need to think about the entire watershed that actually contributes to the discharge of Manila Bay. So watershed, for one, is an area of land in which all rainfall and streams eventually drain into a single outlet. So unfortunately, this land not only captures rainfall, but also carries out pollutants that is originating from communities and people. So when we deal about solution interventions, waste that is generated here and there, we need to think about the bigger picture, which is Manila Bay and the entire watershed that contributes to pollution or the environmental loading that enters the bay. Next slide, please. So for the case of the Manila Bay environment, it is actually composed of the Bataan watershed, the Pampanga watershed, Bulacan, Pasig Marikina, Laguna Lake, and the Cavite sub-watersheds. All of these contribute to water discharge. But obviously, with people all around, that also incorporates all the materials, soils, and solid waste that can eventually enter the bay. And it's very interactive, as can be shown in this figure. There is an interactive exchange of water between Laguna Lake and Manila Bay through Pasig River, and this exchange changes depending on the season. And to make the setup more interesting, our study area is located proximate to Metro Manila, which has almost over 20 million inhabitants. So just imagine how much can we impart in terms of waste and soils entering this water system. So next slide, please. Okay, so for us to sustainably manage the Manila Bay environment, we need to first know Manila Bay. So we all know now that the bay has been utilized for a variety of purposes, being an ideal harbor. It has been used as a shipping port and for the transport of goods and even services. And open water fishing and aquaculture, for tourism, and of course, a habitat for aquatic flora and fauna. But of course, as I mentioned, since people are all around the area, we have our own share of inflicting impact and stress to the Manila Bay environment. So all of this has happened because of forest and mangrove denudation, waste disposal, reclamation and encroachment, because of waste waters and solid waste disposed, eutrophication, and harmful algal blooms, all of which happening in the bay. So because of that, we have an imbalanced system. So what we aim to achieve is a balance for all of this by uh, doing some solution interventions. But again, all solution interventions should be based on science and knowledge of how the Manila Bay environment function as an ecosystem. And that is what the project aims to achieve. Next slide, please. Okay, so the primary objective of Project Smart is to streamline solution interventions to support the rehabilitation of Manila Bay. So with the setup of information using numerical models, no, will now be able to simulate, no, the possible impacts, no, of solution interventions into the bay. No? So we cannot just go through quick fixes. No? Now we can simulate, no, with the setup of a model, simulate, no, what can happen, no, with the bay, or maybe the bay and the lake environment, considering solution interventions, no, that are proposed, no, to Manila Bay. And we will be able to achieve that, no, with the following methodologies. Next slide, please. And framework, of course. So we need to gather data as much as possible. We'll be needing the support of local government units and government agencies, no, monitoring, no, the land, water, and air environment. So using the data that is available, we'll process and assess data, no, which will be useful, extrapolate and interpolate on this data in setting up models, no, that can actually replicate the actual behavior of the Manila Bay ecosystem. And then using this model, analyze and create scenarios, no, that will balance between water resource development and ecosystem conservation. The value of remote sensing and GIS, no, for the spatial interpolation, no, will be valuable, no, for this purpose. So eventually, with such data sets, no, we can generate so much environmental information, and then in forms, no, that will be available, will be able to support decision making, no, to management, so that they can come up with solution interventions, no, that are based on science, no, and information on how Manila Bay actually behaves, no, as a water ecosystem. This can only be successful, no, like any decision support system, if we'll be able to validate, no, the model using data, no, that will come from the people, no, on the ground. No. So considering the geographical extent of our study area, we'll be needing the support, no, of the stakeholders. No. So that considers fishermen, the farmers, local government units, no, everybody, no, on the ground, no, to validate and share information of what they know about the Manila Bay environment and ecosystem. Only through that can we achieve, no, a system, a decision support system, no, that is robust, no, and reliable. Next slide, please. So the methodology goes something like this. We need to characterize, no, what are the forcing functions, no, that move the water in our study area. That may be wind systems, that can be storm systems, or as simple as astronomic tides. And then later propagate these forcing systems, no, into the coastal area of Manila Bay. So once these are propagated on the coastal area, we also need to characterize waters, no, that is coming from the watershed of the bay. And then all of this will enjoy, no, in the coastal area of Manila Bay. Then we can analyze, no, through material transport simulation and analysis, no, the condition of the Manila Bay environment. And this can be done through field surveys, of course, no, to support, no, the data gaps, no, in secondary data. So we'll be going on to field, no, to capture, no, tidal conditions, no, weather conditions, no, the different water quality parameters, no. And aside from this, now we'll be setting up models, no, to replicate, no, how the Manila Bay ecosystem behaves. Next, please. Next, please. So we'll also be doing geosimulation or long-term simulation to incorporate any anthropogenic impact, no, because anthropogenic activities, no, the effects, no, can be long-term. No? We cannot just limit ourselves into analyzing into short-term events, no? And then do model scenario analysis, no, of specific management, no, and ecosystem conservation alternatives. No? With the setup of such a robust model, no, we'll be able to know, for example, the possible impacts of reclamation activities, no, Where will water move, or maybe land cover change, where what will be the corresponding effect, or impact, in terms of water quality. All of this will now be simulated, once we are able to set up, a robust and reliable model. Next slide, please. Okay, so for us to be able to do all of this, we'll be utilizing equipment, um, hydrodynamic, water-based sensors, together with weather-based instruments, for us to be able to capture, dynamic changes, that happen, not only in Manila Bay but maybe including Pasig River and Laguna Lake. Only through capturing, all of these, dynamics, can we actually characterize, the functioning of our study area. And then, of course, all of this data will eventually be utilized, for setting up um, different models. So we'll be utilizing different modeling platforms, for us to be able to effectively replicate how water moves, or what are the corresponding effects, of solution interventions, or even anthropogenic changes, or impacts, onto the bay, and including Laguna Lake also. Next slide, please. So scenario analysis and assessment, like what I mentioned earlier, once we have set up our models, we'll be able to use these softwares, for us to simulate, for example, the impacts of land use and land cover changes here and there, although Metro Manila has been largely urban, as we have shown earlier, the watershed of Manila Bay is actually encompassing, a large part of central Luzon, the southern Luzon also, which remain to be rural, in effect. So any land cover change, can now be characterized, in terms of impacts, into the lake. Also, material transport analysis, in support of what Project Iwasto will be conducting. We can generate scenarios and identify where materials, pollutants, and even dredge materials, can be transported in our water system. This one is a very critical issue now. Reclamation activities, yes, there are different theories, but only by setting up robust, and scientific-based models, can we really assess what specific reclamation activity, or what will be the impacts of specific reclamation activities. Correspondingly, coastal protection, we can also simulate such scenarios. Expected outputs, we want to reach out, to as many as possible, but of course the best way is to generate research based foundation, in the assessment of Manila Bay. So participation in conferences and publications will be important. Patents of the model is possible, of course. And then maps, infographics, web, web-based, or databases, will be generated to support all activities, or policies, inside and outside the bay. Capacitate people, researchers, professors, students, in the use of science, for implementing specific solution interventions, will be accomplished also. Places, capacitate laboratories, the academe, in terms of practicing such scientific-based policy making, or at least science-based, translated to policy making. Next slide, please. Okay, here's a sample modeling output. So if we want to think about pollution that originate from Metro Manila, so we did a simple scenario run of releasing particles that originated both from Pasig River and coastal area in Pampanga and Bulacan. So what you are seeing now is actually an animation of how such particles will be distributed into the bay, using the models that we have set up so far. So if we try to look at it, it seemed like it's almost as if it just takes time before particles will be distributed into and out of the bay and the lake also. But if we try to look into much more detail, if we try to assess it, for example, compare what if this happens during two different seasons, one during the southwest monsoon and the other one during the northeast monsoon. As you can see and compare, it seemed like pollution that is released from different sources will have different distribution in the bay and in the lake for two different seasons. So these are all owing to the fact that the dynamics in the bay and the lake are different during two different seasons. So aside from the distribution of the pollution, it seemed like the timing is also important in recommending solution interventions into the bay. So this is what actually the project aims to contribute into policy making. Science-based information that should guide our decision makers. Okay, next slide, please. Okay, so the project team is composed of the following staff and individuals. We have Brian Hernandez, Jonathan Serrano, Giselle Sumagaysay, Melvin Dangin, Jean De La Cruz, Joy, and Lem, all of which have been contributing to the project since it started in March. But since it started in March 15, unfortunately, that is also the start when we had this lockdown. So we only had one day to really meet and discuss. All of what we've done so far are all online based discussions. So we are, as mentioned by Dr. Tonet, we are now very eager really to go out and contribute as much to the management and policy making of Manila Bay. So thank you. That's all for Project eSmart. Please send us your comments through the chat box and Facebook comment section. Angela, thank you.